There's a few details when you get into constructing a class that's going to be useful to talk about, specifically around scope and the idea of a self-referential variable called this that we're going to come to in a second. But before we start there, let's talk about the big scope. The first thing we need to understand is in Java, I can see anything that's in my current folder because my current folder is what's called my current package. And so, like, if you're in a room with a bunch of people, you can see exactly what they're doing. You can read their body language and whatnot. You can, access them to ask them questions. You can't see what's in their head, but you can interact with them. If somebody's in a different room, then you have to reach out specifically. You can call them on the telephone. You can walk to the other room. You can send them a letter, whatever the mechanism is. And in Java, that's done through the import statement. So if I want to get another class that's in another package, I have to use an import. And that makes it visible to me. Now, it doesn't give me special permissions. It doesn't actually include that code outside of there. It just simply makes it available for me to work with. The package structure in Java, this is a UML representation of it, means that classes live in a package. And packages organize code in an interesting way that have some relation to each other. It might be a functional relationship, it might be a data structure relationship, it might be just convenience, but they have some sort of meaning. So in this case, the ordering system and the sales part are two separate packages. They're two separate parts of the system. But you can use packages however you want to. The practical limitations in Java, though, says that when I say something is in a package, I do so by saying it's in package ordering in this case. It must be in a folder called ordering, and the file names must match as well. We talked about that before. So the file names order and order.java. The folder name ordering must match the package name, and that package name must match all the way down to the source folder. So if I put packages inside of other packages, then I say ordering dot shopping cart, then I'd have to say I have a folder called ordering and a folder called shopping cart, and vice versa. Java really cares about the structure of the code and the structure of the files that's used to maintain and build that code. All right, so beyond the packaging, then we get into individual classes. There's many levels of visibility and scope inside the classes as well. So we start with the class scope, which we've talked about is all the attributes, all the members. But then it goes down into the method scope, the block scope of like an if statement or a for loop, and then individual blocks that we can create in our own. Each one of these new sets of curly brackets creates both a block and a new scope. So inside this innermost, this yellow over here, this innermost scope, I can see everything outside of it, but not the other way around. So this method do stuff cannot see the variable block variable unless you're inside this block. So this method do stuff can't see anything that's declared like the if variable that's not defined once you leave the if statement. And this helps me manage variables. It means that when a variable is created, it doesn't live forever. Java can clean it up when you're done with it. And it also helps me not have to have a whole bunch of variable names, that I have to make up, temp1, temp2, temp3, because I can use blocks to my advantage. So in this example here, let's say I just have a temporary swap variable. Well, I can always go through and declare a block just anytime. I don't have to have any parameters coming in, just a block that says I have the swap variable, and it's going to say swap variable is x is equal to y is equal to swap variable, and I've swapped x and y. If I need to swap x and y later in the code, I can copy and paste this entire block and move it over, and I don't have to worry about redeclaring or running into the exact same swap variable. So this is one strategy for managing blocks and scope by ensuring that data only lives as long as you want it to, and it doesn't. I mean, it's kind of like shredding a paper when you're done with it. Somebody sends you a bill, you pay the bill, you shred the bill, so nobody gets your account information. That's the same concept here. All right, so one note on that is constants then are only constant within the scope that they're defined. So for instance, if I had this code inside of a class, the social security number is going to be unique and final for each person. It's not that everybody has to share the same social security number. Each object has its own social security number and it can't change. But then this final down here inside the method, every time somebody runs do stuff, I might have a different value of J that's saved. So, a constant is only constant for whoever can see it. Each object can have its own value, and then each method can have its own value, and each block can have its own value. So there can be thousands of J's running around the system at any given time. But within this method do stuff, we know that J can't change. That helps us really, as I said, manage our assumptions about code. So the other thing I want to bring up here before we jump along is this idea of a self-reference. This relationship between the class and the object, because this is very much about scope as well. So in Java, it's called this. And this is the concept of, let's say you're reading a self-diagnosis, pamphlet. And the pamphlet is talking about having coughs or chills or sore muscles or runny eyes or whatever it's going to be having. Well, you implicitly know that when you are reading that pamphlet, you're talking about your own symptoms or somebody else, your kid's symptoms or your friend's symptoms or something like that. You implicitly apply the abstract rules of the pamphlet to that. Now, Java sometimes does it implicitly, sometimes it does it explicitly. It requires you to do it explicitly. So in this example, I have somebody called this method do stuff. Well, remember, class methods are generally for any object. So I need to know which object was it called on? Was it called for me or my kid or my grandma? Who am I checking out the symptoms for? Well, the this says it's for me. Now, most time in Java, I'm not confused about that. If I have a pamphlet and checking out the sick person, I'm not sick. Clearly, I'm not talking about my own symptoms. I'm talking about somebody else's. But in other cases, there are times where I can say I don't need to put the this inside there. When I call get ID, there's nobody else in the world that has an ID except for the object that I am, and it implicitly calls this. But up here, we can see when I pass in an ID, the attribute ID has the same name as the parameter ID. Java allows this, right or wrong, because of the this statement. So when I say this.id, it refers to the member, as opposed to ID by itself, it refers to the local variable. This is good and bad. So you need to really understand when you're passing something in and when you're defining variables, because what could happen if I just said ID is equal to ID, the object would never be updated. And so you can accidentally define a variable for something that overlays an attribute in your class and it never updates the class for it. So it's something to be aware of in Java. It's an advantage and something to something to take advantage of. You can if you're comparing two objects, I can say, well, is my time greater than or less than your time? That's like we did in the clock problem, right? This comes in very handy at that point. But in other cases, it can be confusing and difficult as well. All right, so there's a little bit about some scope. We don't mess a ton with scope in data structures, but we definitely do want to protect our data structures. We want to hide things. So we basically, the scope is hide everything and run from there. But sometimes in hiding things, you have to understand where you can access and also where you can't access certain data items. And then how do you adjust your code accordingly.